Hello, here we have a video about using an electronic charting system. That's some navigation program, the official name Electronic Charting System, ECS. Using that for navigation, doing depth sounding navigation, as a way to illustrate how valuable these programs can be with charts and program technology, even if you have lost your GPS, have no GPS signal for some reason, which is not out of the question. So the technique we want to do now is a traditional log of soundings navigation, and the situation is this. Let's say the vessel is somewhere over here. And this is some uncertainty of a couple miles this way. We're somewhere here and don't know where we are, but we're headed this way, headed down this way, course 110 in this example, and we're headed right across this gold mine of depth sounding navigation bathymetry here. So we can find out very closely where we are. Now, what's the requirements here? We have to have a depth sounder that's calibrated. That's a fairly easy instrument to calibrate. And then we have to take into account the height of the tides. And we have other articles about this that show the corrections, how deep is the depth sounder under the water and so forth. What we want to log ultimately is the actual charted depth, removing the effect of the tide and correcting for the foot or two that the sounder is under the water. And then we can move along there to collect data. And the way we might do it is, and I'm using qtVlm, which is a very good program for doing this type of training because it has the tools and simulation that we need. So let's see, where's a sharp place this is changing. Actually, let me just put the boat right here and then head down this way. So I'm going to just move the boat over here, move the boat here. Actually, let me get it right down there close to the contour. Okay, and then turn on some instruments, and I have set up to watch the course through the water, the speed through the water. That's a knot meter and a heading. Speed through the water, and the depth, and we're plotting the depth. This is a tool that will plot the data. A lot of programs, for example, Expedition has beautiful, elaborate plotting techniques like this. But this is qtVlm has a system that works too. So we're going to go this way, and so let me just see. I think I can just start the simulation. Command S. I'm turning on the AIS. AIS boats might show up here. And now, okay. So I've set this, what's my boat speed here? I cranked that boat speed way up to 30 knots, just so you can see this happen as we're going across here. So we're reading the depth. This is in feet, I think. And then here is this graph that's collecting the data as we go across. And qtVlm can do this because it has a simulated sounding based on, for example, vector chart elements, and then depth area. So you see, the ENC charts know these depth areas, and so qtVlm has set up this very nice, for practice, a way to simulate the depth. Now, your actual depth sounder is not going to just change at these contours. It's going to be a smooth curve measuring the actual depth it reads as it goes along here. But for practicing, this is a really powerful tool for practicing to see how this works. Okay, so that's how it works. And you collect this data, and you can set up whatever instruments you want down here and so forth. You can drive the boat, different ways like that. Okay, Command S. Okay, so I'm done with the simulation. And I guess I don't need the instruments up here anymore, so I'll shut the instruments off. And now let me show here, what do I have here? Here's one. I did a couple of these. Just for practice, I ran across this reef that way, and you see the kind of trails that you get like that. You can do that with practice. Here's another one like that, and so forth. And then you can put the cursor. Let me actually show that on a reel. Okay, so and then I can go on here and read the value and the time. And then once I know Well, okay. So the idea is, once you have a track like this that you can go in here with your cursor and read what time I was at 300 feet. That would be my 50 fathoms. And then what time did I hit 50 fathoms again? And then 120 feet. 120 feet here is somewhere here. And then 120, that would be the 20 fathoms. So that's 20 fathoms and 50 fathoms. And the experimental case I did, I went across in our unknown area here, marking the times that I hit the 50. Oh, these are feet and feet. Let me see. Okay, so I actually did this on a raster chart. Let me switch to a raster chart. And so we're here, and we're somewhere here, and this is where I went across. Okay, then the data looks something like this. I went from 50 fathoms to 20 fathoms in a distance of 0.76 miles. Now that means I get the time, T1 to T2, and I'm going 6 knots so I can figure the distance. And I just wrote half of this, and you're going to see why I did half in just a minute. And then I went from 20 fathoms to 20 fathoms across the top of the bank here, at 0.94 miles, and half of that's this. And then I went 20 to 50 going down this side of, let's see, what am I doing? I'm going back down into deeper water. These banks are really amazing things. If you look at this is 7 fathoms, this is 72 fathoms, and then you draw that out, it's like an island that's just had its top cut off just below the water. So these and the Pacific Northwest up here in the eastern end of the Strait of Juan de Fuca has these banks all over everywhere. And back in the days before before Loran, I'm a little bit embarrassed to say, but in those eras, sailing a lot in that particular area, we did this for real. This was real type of navigation in the old days. Now, it is a backup to when your GPS fails. But the good navigator is prepared with this technology, and since you're going to have, or I would recommend should have, some electronic charting program working for you, then you have these powerful tools here. Now let's just look how to analyze that. Okay, so here's the trick. And they're right over here. I made them. I'm going to pull this over a little bit like this. So what I did was I made a mark. What's the first one? Oh, where's my picture here? Oh, okay. I'm going to have to get that out so I don't lose that. Oh, am I going to lose it every time I touch this? Wait a minute. Okay, excuse me. Let me do a little logistics here. Okay, so every time I touch this, I'm going to lose that. So, okay, so there's what I'm after. Oh, okay, so I did 50 to 20. That's this first one. The first contour I'm going to hit is 50, and then I'm measuring it from 50 to 20. So, and that has a distance. So what I would do here, where is 50 to 20? Is this the 50? Yeah, this is the first 50 to 20, and that was 0.38 miles. So I make a mark. So here, let me just show you. So I do edit. So I make that mark. I just named it 50 to 20 equals that much miles. And then you go down, and I put one ring on it, one range ring, and I put it at half the distance. That's why I wanted to do that math ahead of time. So that's half the distance. So that this marks this distance here, which I can now sniff around with, I can sniff around on the chart, marks this first gap doing the fifth. In other words, I went from this contour to this contour in this distance. So I can do things like move this guy over here now and just kind of look. Okay, I know I'm somewhere in that area. So what about up here? So 50, I'm not up at that end. Look at that. That's way off. 50 to 20 is way off. And down here, it's close. I'm not really sure, but it's somewhere, 50 to 20, somewhere around here, something like that. Okay, I'll let that go. Now, what the next one is 20 to 20. So the distance across the flat top of this thing was this one, and that took place in 0.94 miles, and so I made my range ring at 4.47. So you bring this guy over, and you see, okay, so look, obviously I'm not crossing up here. There's 20 to 20. No way, right? That's 20 to 11. And if I come down here, here's 20 to 30 or 40, so I'm not there. And so you see, I can pretty much lay this thing right up in there. So somewhere in there, remember, I'm going 110. So that's also reminding me, I haven't drawn the line 110 on here. I could draw a line in direction 110 as a guide for where to put these. And then finally, you could bring in, just to kind of convince yourself what's going on, you see, this is obviously not down here, 20 to 50. I don't get to the 50 there. And up here, I'm way past the 50, and you see it fits right around in here. So the point is, what I found with this navigation, which is really, now it's taking me almost longer to tell about it than it does actually do it. But my position at the end of, when this last data point was taken here on that graph, which I have the time, right? I have the time right on that histogram. That's my position was somewhere right here, just coming off this bank at right about this point. So that is the technique. And that can be done with a lot of programs. We use this particular one. Okay. Let me just mention one last thing. Another thing you can do and practice very nicely with qtVlm is another standard old days navigation, depth sounding navigation technique. Namely, you go along a coast and you take a contour that's sort of following the coast at about the distance off you want, and then you just follow that contour, seeing that you're not shallower than that, you're not deeper than that, and so forth. And this program, I'll maybe follow up with another video on that, but this program will also train with that exercise very nicely, and there are tools of the histogram, this graph, is a secret there to making that easy.